Hello, hello, hello. Today is Tuesday, June 13, 2023. Problem 173. A slingshot encounter. This is what NASA does all the time to get a spacecraft to a certain location in the solar system. It uses other planets to increase its kinetic energy. All right, so let's read with me. Spacecraft can gain in mechanical energy as they encounter a planet. This may appear as a violation of the conservation of energy, but it is not. The gained energy is at the expense of the orbital energy of the planet. So think about this for a minute. So the planet goes around the sun, has an orbital energy, kinetic energy, and at the expense of that energy, the spacecraft can increase its energy. Let the spacecraft have a mass m, lowercase m, and a velocity v, lowercase v, just before the encounter. The planet has a mass capital M and an orbital velocity capital V. Both velocities are relative to the Sun and they are in opposite directions. Assume that the spacecraft rounds the planet and departs in the opposite direction. Thus, after the encounter, the velocity of the spacecraft is in the same direction as capital V. First question, what is the speed of the spacecraft after the encounter in terms of lowercase m, capital M, lowercase v, capital V? Second question, the speed of the spacecraft just before the encounter is 10 kilometers per second. And the orbital speed of the planet, I have selected Jupiter, the orbital speed of the planet Jupiter is 13 kilometers per second. It's a hair larger, but let's just stick to 13 kilometers per second. What then is the speed of the spacecraft just after the encounter? Last question. If the mass of the spacecraft is 2,000 kilograms, how much energy did the spacecraft have before the encounter, and how much energy does it have after the encounter? And you will be amazed how much the kinetic energy of the spacecraft has increased. Yes, all of this is the consequence of Newtonian mechanics. This is a high school problem, no doubt in my mind. But if you can't do it, don't feel bad. It certainly will be a JAE normal problem. Probably not a JAE advanced, because this problem is too simple for that. If you can't do it, don't feel bad. Watch my solutions and you learn some physics.